Welcome to our YouTube channel, where we are basically trying to present mathematical lessons. So in this presentation, we are interested in looking at the introductory part of travel graphs. Now, when we are dealing with travel graphs, basically we have got two approaches or two categories that we must look at. The first part is the distance time graph. Then the second part is the speed time graph. So in this presentation and in the next presentation that is to follow, we are going to concentrate on the speed time graph for obvious reasons. Alright? So now, in order for us to be able to understand or to deal with this aspect, there are other sub-headings that we must understand, or there are other concepts that we need in order for us to be able to do it effectively. So we are going to deal with the acceleration, distance. From there, we also look at retardation, okay, as well as the average speed. Alright, so we have acceleration, distance, retardation, and the average speed, which I'll be able to explain in an example. Alright, now the first point is acceleration. Now, acceleration simply means the rate of change of velocity with respect to time. The rate of change of velocity with respect to time. What that means also is that for you to say an object that has accelerated, there are two things that you must consider: velocity or speed and time. Is there a change in velocity or speed? Right? If it is yes, then come in time. Is there a change in time? If it is yes, then you know you're dealing with acceleration. But if there is change in time, but there is constant speed, then the acceleration is zero. Alright? Now, how do you define that mathematically? We say acceleration that is denoted by A is equal to V minus U over T in meters per square seconds. Now, what is V? V, that is the final velocity, and U is the initial velocity, T is the time taken. So if an object has at least, so at least is the initial velocity, then it moves or travels for about 10 seconds in maybe at 15 meters per second. So since it is coming from rest, so that rest, which is a zero, is the initial velocity. The 15 meters per second is your final velocity. So we are saying V minus U over T, that's the formula for acceleration. But remember the unit should be meters per square seconds. Alright, alternatively others would write this as M S to the power negative 2. It's one and the same. That's another way of representing this. Okay? So I say A is equal to V minus U over T. I will be able to see that clearly with an example. Then, if you want to find distance, basically we are saying for us to be able to find distance, we should be able to identify the graph. Alright? So distance is given by the area under the graph. So identify your graph. Alright? So if your graph is in form of a triangle, then you're going to apply the formula for the area of a triangle. In this case, we're dealing with the right angle triangle. So if your graph is in form of a square, you apply the formula for the area of the square. If your graph is in form of a rectangle, you apply the formula for the area of a rectangle. In most cases, these are the expressions that we deal with. These are the graphs that we are going to find. Either a trapezium, a triangle, a rectangle, or a square. So if you know that my graph, right, is a trapezium, how does a trapezium look? It is in this manner or in this form. It looks like this. So in this case, if you have identified that this is a shape, we are saying this is a trapezium. But how do I get this distance? By distance, we mean the distance move from this point up here. Alright? So if the the object starts from here, it moves all the way up that point. We would want to find the distance of this graph. The distance of this graph. So how do you get the distance? Identify the shape. Alright? When you identify that the trapezium, you apply the formula for the area of the trapezium, which is d is equal to half by d mean distance is equal to half times the height times the sum. Here, what is our sum? We are saying a plus b. Right? Now, others would rather put h at the end, but it doesn't matter. Multiplication is commutative, it doesn't matter. 2 by 3 is equal to 3 by 2. Right? So now, when you know that I'm dealing with a trapezium, and this is the formula to use, what is important here is to understand how to apply this formula. Alright? Now, if you look at our graph here, we are saying the formula is half h. Now, what is h? What is our height? Height is always the line that meets or joins the two parallel lines. So, in this our graph, we have got this line from here up to there, which we are calling A. Then we have another line from here up to there, which we are calling B. And these two lines are parallel. So, if we were to draw a line from this line to the other parallel line here, so this line that we are going to have here will be your height, regardless of the position. Alright, so our height will be this. So if here it is 4, then we are going to put 4. Then what we are going to do now is look at your A and your B. Okay, so these two can be interchanged, doesn't matter. The order doesn't matter. You can say, okay, this is my A, this is my B, or vice versa. Okay. Again, here you must be careful how to get A. So we are saying for A, suppose this is 10. And here it is 30. Alright? So your A, we are saying the distance from 10 to 20 at 30. And the difference there of what? 20. So you say this minus that. If this is 0 and this is 50, it means your B, you are going to say 50 minus 0. So your B becomes, your A becomes 20, your B becomes 50, and suppose our height is 4, so h becomes what? 4. Then you take this and you plug them into the formula. Okay. I hope it's clear. Now, what I said, in most cases, I'm sure you've already picked this. In most cases, even when we have this kind of an arrangement, okay. So the distance from there up there will denote our A. Then the distance from here up there will be B. Then the distance from this point to that point will be our height. So you can still use this, or you can still follow the formula for a trapezium to apply on this one to find the distance covered made from this point up to that point. So what I'm trying to say is the height here is not that the height always goes up. No. We are saying the height should be able to join these two parallel lines. Okay? The next one is, if you have identified that your graph or your shape is in the form of a triangle with a right angle, you are going to say D is half BH. Alright? Where this is your base and that is your height. I'm sure that one is straightforward. For a rectangle, you have length and the breadth here, which is L times B. Now, how do you tell that the rectangle when the sides are different? For a square, the sides should be the same. Others would rather use L, which is length, or length. It means in the other side it will be length, or side. Doesn't matter. These are just representations. Okay, but the good news is between these two, even if very critical here is this, the trapezium. Because if you're not careful, especially on the height, you tend to make mistakes. Alright? Now, for retardation or deceleration, we are saying for retardation or deceleration, it is a negative acceleration. We have said that acceleration is not v minus u over t. But we are saying now, retardation is the negative only. When you introduce a negative and you factor it in, you get this negative and slot it in. What will happen is that this one becomes negative and this becomes positive. So, in short, we are saying retardation is equal to u minus v. But now you must be careful when dealing with u and v in this case. I think we'll be able to demonstrate today. Okay. So, we are saying for retardation, we are saying it's the negative acceleration, which is u minus v over time. Alright? Then another aspect that we need to also look at is average speed. So we are saying average speed. How do we get the average speed? Average speed is you look at the total distance traveled. If, for example, I'm looking at the distance traveled by maybe an object from this point up to there. So you the average speed that is. So you look at the whole distance traveled. Okay? Then the distance is 200. You say 200. What is the total time taken? You say the total time taken is speed. That is average. But why are we talking about average and not just speed? Okay? Because we realize that when you are traveling, you may not be traveling at the same speed. Alright? Sometimes you can increase speed, at times you reduce. So for you to find the speed for the whole journey, you get an average. Alright? So that's why we go for the average speed. So get average speed, get the whole journey, the whole distance covered over the total time taken. I hope these points are clear. Alright, so we have an example on the board here. We are saying the graph below shows the speed, which is v. In meters per second, and the time taken. So the time taken is in seconds. Okay, as you can see on the board. So let me just quickly put up the questions there. So A, or the general question would be, find the A acceleration in the first 10 seconds. B, distance covered in the first 40 seconds. C, acceleration between 10 seconds or maybe say between the 10th second and the 40th second. D, we can also look at retardation. Retardation, I think that is okay. Then So I'm sure these 5 questions represent all the points, all the concepts that you have elaborated. Okay. So now, all right, so we say solution. Then here we can emphasize the average speed for the whole journey. Yeah. Okay, so here we say A. So we are saying let's get acceleration here is the situation. In the first 10 seconds. So we are saying we can recall the formula. Actually, it's here. We say acceleration is v minus u over time. So we can write A is equal to v minus u over time. Now, what is that v and u as well as t? So we can see that the object is starting from this point. Alright? So it moves with a speed of 15 meters per second for 10 seconds. So since the object is starting from here, this side, the vertical axis represents the velocity. Then the horizontal axis represents the time in seconds. So if I'm given the velocity, my initial here will be 0 up to here. So at this point, my final velocity is 15. So my initial velocity is what? 0, but my final velocity is what? 15. But what's the time taken from this point up to here? It's a 10 minus 0, which is 10. So you have 15 minus 0 over 10, or 10 minus 0. So this will give us 15 divided by what? 10. So we can find the common factor here. It has common factor. Which is what? 5. 5 here will give us a 2. 5 there will give us a 3. So since this is an improper fraction, we can still divide it. So say 2 into 3 is 1. Remainder 1 over 2 meters per square second. That is our acceleration. So from this graph we can see that from here up to that point, the graph is going upwards. So at that point here where the graph is going upwards, we have acceleration. But here at the end in the last 10 seconds, the graph is going downwards. So from this point up to that point, basically we cannot say there is acceleration. We will say there is retardation. If you are dealing with acceleration, then you say there is negative acceleration. Okay. B. Distance covered in the first 40 seconds. So we are saying distance, remember we said distance is defined by the graph. You look at the area under the graph. So in this case we are saying we want to find the distance in the first 40 seconds. That is it from here up there. So this is the whole of this. So now, when you look at this, so you ignore this part. So when you look at this shape that we have here, we have a rectangle and a triangle. So you can get the area of a rectangle and area of a triangle. Or alternatively, you can still borrow the formula for a trapezium and apply on this. It will be able to give us what we want. So we are saying half times h times a plus what? B. So distance is half times, the question is what is our height? Look, we have this line from this point up to that point. So we call this A, from 10 to 40 seconds. Then from 0 to 40, this is what? B. So these are two parallel lines. So the line that will join them will be our height, even here. And you realize that the distance from here up to there, look at it in terms of the distance, but of course velocity. But in terms of the number, just it is 15. So from here to there is 15, from there to there is 15. So our height there is 15. So we have 15, open bracket. What is our A? Our A is from 10 to 40. What is the difference? 40 minus 10. The answer is 30. Very good. Plus. Again, our P is from 0 to 40. What is the difference? The difference is 40 minus 0, which is what? 40. Good. So now we are going to say D is equal to half times. If you want, you can divide D, or you try to work out what is in the brackets. You say 30 plus 40 and answer what? 70. Good. So now, you might avoid getting the decimal numbers here. You say, what is half of 70? 35. Alright? So you have this 15 by what? 35. So usually this number is equal 1 and you don't need a calculator. So how do you work out this one? You just say 35 by 15. Okay? This by that is 25. You take 2, this by that, that's 15 plus 2, 17. Okay? This by that, that's 5. This by that, that's 3. Here you put a 0. Then add 5, which will give you 12. 2 and 1. This is 4, 5. Okay? So the distance is, our distance is equal to 5, 25. But the SI units for distance are meters. So this is 5.5 meters. Okay? So I said to get the area, to get the distance, identify the area under the curve. If it was the first 10 seconds, you would have said, oh, what is this shape? You would have said, okay, the shape is a triangle. Hence you apply the formula for the area of a triangle. Between 10 and 40 seconds, you identify the area and say, oh, okay, the shape is a rectangle. Apply the formula for the area of a rectangle. If you're looking at the last 20 seconds, triangle, apply the area of a triangle. The total distance, you apply trapezium. Okay. I hope that is clear. Okay, so let's go to maybe I can still erase the top part. I don't want to erase the dark one. Okay, so we deal with the C. Okay, so what is he saying? Acceleration between the 10th and the 42nd. So when you look at the graph from 10 to 42 seconds, which is this. So you realize that the line here is the horizontal. Where there is a horizontal line, the acceleration is 0. When there is a vertical line, the acceleration is undefined. Okay. So now, from 10 to 40 seconds, the line here, there is no change. There is change in time on the right, but there is no change in the velocity because the velocity from here is 15. Hence acceleration here, acceleration there is 0. Right? Acceleration is 0. That's the answer. So now, D. We want to get the retardation. Okay. We want to get the retardation. So say retardation is equal to U minus V over time. Now, when we are dealing with this part, we have to be very careful. So it's very critical here. Now, we are saying U minus what? V. That U is not this U as we are dealing with acceleration. We are saying at what point are we starting to reduce in speed? or to decrease in speed is at this point. So since we are starting to reduce in speed at this point, so my initial velocity becomes 15. Alright? Minus, so we reduce speed from this point all the way up here. At that point, what is my final velocity? My final velocity becomes what? 0. But what's the total time taken? This minus that. 60 minus 40, so we get what? 20. This will be 15 over 20. Now the common factor here is a 5. 5 into 15, 3. Divided by what? 4. This is okay. Or it is 0.75 if you want to divide it. That is our retardation or deceleration. Okay, then the last part. I hope now you've got everything. Maybe I come here. I just want to keep that happen. The last part, which is the average speed. We are saying we deal with distance traveled over time taken. So, in this case, we want to find the average speed. We are going to example the fact that from here up to there, the speed was increasing. Here, the speed is the same. But from this point up to here, the speed is decreasing. So we do not have the same speed. And because of that, we get the average. And now, how do we do? Let's get the total distance from this point up to that point. So the first thing is identify the shape, which is a trapezium. So for distance here, our distance is equal to half times height times a plus b. So our distance will be half times, what is our height? Our height is 15. What is our a? A remains from here up to there, which is 20, 30. Alright? 30 plus. What is our b now? Since I'm dealing with the whole graph, so my b will no longer be 40, but in this case 60. So you have what? 60 here. So this is equal to half times 15 times 90. So like I said, you avoid the data point. You can say what is half of 90? 45. So you say 45 times 15. You say 45 by 15. Okay? This will give you 25. So 5 take 2. Will give you 20 plus that, you get 22. 1 by 5, 5. 1 by 4, 4. You bring down a 0, then you add. This is 5, 7, 6. So the total distance there is 675. Alright? So we have our distance being equal to 675, and the SI unit of distance is meters, so we put meters here. This is our distance. And that's what our final answer. We are interested in getting the average speed. So say average speed is equal to, what is our distance now? 675. What's the total time taken? In this case, it is 60. Okay. So when you have set numbers, we need to begin to reduce or divide bit by bit. So my average speed is equal to, correct? So we can say, maybe 67 is what one? 60 into 67? It's 1. Remainder? 7. So we put 7 here. So what is 60 into 75? You have got 1. What is the remainder? You have 15. So what we have is 11, 15 over what? 60. But you can reduce this. Alright? By finding a number that can divide between this and that, we'll get the highest common factor. And in this case, the highest common factor is the 4. So you can say you have 11, actually 15. So 15 here, you get a 1. 15 here, you get a 4. So I've got 1 over 4 meters per second. Each one can give it as a decimal number. That is our averaging speed. Okay, friends, that's where we end here for today. I hope this is very helpful. Thank you so much. I almost forgot. As our practice, we always give an exercise. So with me, I have an exercise. So what I'll do, because of time, you can just be able to picture it. Okay. I hope it's very clear. I'm trying to adjust it so that you can be able to see.